Welcome back to my channel. I hope you are doing good. So today we are going to discuss a very important topic, and this particular questions are very much asked in a data engineering interview. I have found that there are multiple candidates, there are many who are working on some different domain like QA, data analyst, software engineering, and uh, multiple other domains, and they are trying to switch into data engineering domains, and they go through some course, and after going through the course they are actually good with the theoretical part, but as they don't have that many hands-on on a project, sometimes interviewer asks some tricky questions, and these questions they are not able to answer. And so I have list down some of these tricky questions which interviewer often ask, because this type of problems are actually faced in a data engineering domain, and those who have worked in a data engineering domain, it becomes very easy for them, but those who have not worked in the data engineering domain, it is little hard for them to answer this type of questions. So we will try to target one question today, and we will keep on solving some other questions. So it will help all those candidates who are moving from some different domain to data engineering domain. And if someone is already working in a data engineering domain, they can also watch this video. I will try to write very modular code. I will try to explain in a very crisp manner. So without wasting time, let's get started. So let's try to understand from the data engineering perspective. Okay, so who are data engineers? Data engineers are someone who are mostly writing data pipelines, the big data pipelines, right? And in the big data pipelines, they are mostly concerned about the ETLs. When I say ETL, it means extract, transform, and load. Okay, so what does extract means? Extract means loading data from some source. What does transforms means? Using writing your business logics to transform your extracted data to get the desired data frames or the desired input. And what does load means? To load the data to some distributed storage. Let it be S3 of AWS, let it be SDFS of Hadoop, let it be cloud storage of GCP, or anything like that. Okay. So there are multiple problems and the multiple interesting use case which comes into pictures when you are dealing with the extract, transform, and load. So today we will try to figure out one of the problems of extract. Okay, and we will try to explain it by writing our code. We will try to hands on, we will try to write the code and try to understand. So let's move to the questions directly. So what is the questions? So interviewer might ask you that, let's suppose you are having some relational database. Let's suppose you are having some Postgres database, and it has TBs of data. It means it has very big data. Okay, how? Let's suppose you are having a Spark, and a Spark is a general purpose computing engines. We all know, right? So we can use Sparks to get data from any relational database. Then he or she might ask you that, let's suppose I'm having very big data, and my code is working fine today, but tomorrow my data becomes very huge. How do you write a elegant code to fetch the data from that Postgres or the Oracle or Microsoft SQL Server, MongoDB, any relational database or any database? How you will write your Spark code to which will help you to load the data from the source to the Spark? So I have seen that those who have gone through some course, they directly give the answers. What they say? They say that we will be create some JDBC connections, and using that JDBC, we will try to load the data. So, but actually that is not 100% correct. Whenever you are doing a JDBC connection, it's not actually optimized. So let's suppose your Postgres can have 10 concurrent connections open. Okay, so you want to load your data parallelly, right? So there are multiple way in which you can do the same. Okay, so let's try to see. So how you are going to write the normal code? You can write something like df, or I have already written. Let me just show it to you. Okay, so what you will do, you will write spark.read.format, And the options you will pass the URL. One minute. What you will pass the URL, the user, password, okay, and database name or D table, whatever you call. Okay. So when you are writing your code like this now, it will actually create a single query, and we are not getting any benefits out of it. If your data is very big, it is not the optimized code, then how we can do the optimizations? So we will go through the database and we will try to see, does this database has some numeric or timestamp column. Okay, let's suppose your database has some primary key. Let's suppose your database has some ID, and the mean value of that particular is 1, and the max value of that is 10,000. So what we can do, while creating our JDBC connection, we can specify the lower bound of particular columns and the upper bound of particular columns, and we can specify number of partitions. So let's suppose our number of partition is 10, okay, and my partition column is ID, and if I specify that my lower bound is 1, perfect, and my upper bound is 10,000. Okay, so how a Spark will create query now? Instead of creating a single query like select a star from your table name, Spark will also place where clause, and inside that where clause it will pass ID is greater than equal to 1 and ID is less than equal to 1000. It will again create one more query. It will say ID is equal to 1001 and 2000, and it will again create one more query. (2001) and 3000, and it will create, as we are having 10 partitions now, we have specified number of partition is 10, so it will create 10 partitions. It means 10 query, and it will just open the 10 connections in the Postgres, and it will just dump those 10 query to the Postgres, and concurrently it will fetch the data from that Postgres server, Oracle server, MicroSQL server. And this is the optimized way, because in what you were doing previously, you were only loading the data, right? Loading data using single query. You will not utilizing the where clause. Now your Spark has created 10 query, and now the 10 query will be sent to the Postgres individually, and concurrently it will fetch the data. You are getting it? That's the benefit of using number of partitions. It's very easy concept, but the problem is that no course teaches you this type of small optimizations, and people who have not worked on who doesn't have the hands-on on project, they actually don't know these things. Okay, so we can pass, we have to pass one number of partitions, we have to pass partition column, then we have to pass lower bound, then we can pass upper bound. Cool. There are multiple things which we can do. Let's look through the documentation itself. Let me just open JDBC fetch Spark. Okay, when you look through the documentation of Spark, you will find that there are multiple things that you can do. Instead of sending DB tables, you can actually pass query, and inside that query you can write your complex query or some filter statement or something like that, or it becomes very easy. because that what the Spark will do is Spark, instead of creating their own query, Spark will just take this query and just send it to your Postgres server. Okay. Now this we have already understood, right? Partition column, lower bound and upper bound. We will also write our code. Number of partition we already explained. Then we can also specify the fetch size. So these are some of the optimizations that you can learn, that you can see, that if you specify the fetch size, that amount of data will only be fetched, and it is very much helpful, and it actually optimize when you are having very large data in any relational database. Okay. And by default, predicate pushdowns is true. What does predicate pushdowns means? Predicate pushdown means, let's suppose you are writing some filter statement on in your Spark data frames. That filter statement will be sent to the source itself. Okay. And if so, when the Spark will create the query, it will actually add your where clause, because every other things is transformation in Spark, right? It will be lazily evaluated until some action is called. So let's suppose you have written something and then you have written some filter. If you have written some filter, it will take those filters and it will actually send those, create one query where it will add the where clause and it will send it to the Postgres server, right? You are getting it? I hope you are getting it. We will also write the code. It will make more sense to you. There is something called predicate grouping. So let's suppose you are trying to get data from some very strong server. Let's suppose you are trying to get the data from BigQuery or some very highly managed Oracle server, and you are very sure that you can apply the group by there very fast. So what you can do, you can actually on the predicate that this particular options push down aggregate. What this push down aggregate will do, this will actually send your group by to the Oracle server or the Postgres server instead of applying that on Spark. But let's suppose your source is not that much strong. It is not advisable to on this particular keyword. Okay. So, and by default this push down predicate is true. Let's read it. What does this documentation say? It says that the option to enable or disable predicate push down into DGBT data source, the default value is true, in which the Spark will push down filters to the JDBC data source as much as possible. So वो क्या कर सकता है, वो जितना भी फिल्टर्स मिलेगा ना उसको सोर्स पे डाल सकता है. They can actually take the filters and Spark can actually send the data to the Postgres server. Okay. Oh, enough of theory. I hope you are getting that. We can do something. We can do something if our data is very large, and we can actually fetch the data. Okay. So let's try to do one thing. Let's try to write our code. Let's try to write very modular code which you can use in any of your program. Okay. I've already written code for you, but we will try to write code from very scratch. Okay. So it will become easier for you, and I will also give you my GitHub link, so it will become easier for you. Okay. Let me just create one object, Scala object, and let me just call it util demo. For me it is object. Okay. The first function I will be writing is def get data, and inside it I will be passing Spark. That's the Spark session. Cool. Inside that I will be passing configs. Perfect. And will be map of string comma string. What this will give me? This will give me data frame. Let me just import it. Cool. Here we will be, and let's just pass the read type also. For now, don't worry about the read type. In our next video we will understand what does this read type means. Full load or full read. Okay. We will say let's extracted df. Let's use the case switch or case whatever you called. Read type match. We will say full load, then just call one function, get full data, and we will create one function, let's say incremental load. Let me just write incremental data. Okay. Why I am writing code? Because I am making this video for someone who is doing some course, who are doing some course and they don't have that hands-on. So I just wanted them to see that how we actually write the code in a good way or in an elegant way. Otherwise I could have just shown you the code. I've already explained you the concepts, right? I'm just trying to write the code so it will be easier for you to understand. It will be, and you will also have some idea that how to write the code. Okay. For now, I'm just throwing one exceptions. For now, we only support full load and incremental load. Okay, let's just create these functions. What we will be passing? We will be passing a Spark there and the configs. Spark and configs. Cool. It will return data frame. Let's create this function. For now, don't worry about incremental load. I'm just creating so you have the idea that we are going to do something in the next video. For now, we will be focusing on JDBC connection. That's it. But I'm just creating a dummy functions for now. For now, just worry about the full load. Here, let me just return some dummy value and let me just write to do. Okay. 1 minute. Cool. Let's try to create the let's try to call one functions which will set our JDBC options needed. Okay, so we have seen that we know this type of options, right? These types of options to call our JDBC connections, right? In the end you will say that we do call our functions like this. This is for write, the same applies for the read, as you can see, right? So we need all this key value pair, right? Okay, so we will be trying to create it. Set val JDBC options. Let's call one set JDBC option. Okay, let's pass config there. For now, spark dot empty data frame. Cool. Let's try to create this function. And let me just copy it. I don't want to type it. Perfect. What it will return? It will return some map. Cool. String. Perfect. Okay, let me just pass spark and configs. Cool. Okay, so let's try to create the basic things that we required. Options is equal to let's try to create one mutable map. Mutable dot map. 1 minute, let me just import it. Okay, dot map, because I don't want to keep writing things, so I will just say rename it mutable map, and I will use the mutable map here. Instead of using map, I will use the mutable map because I want to mutate it, right? So I'm just using mutable map. I could have used var variable, it doesn't matter actually. It's just that I just wanted to, I am not fan of using var, so I am using val. Okay, URL. Okay, we will be passing something. I don't remember the value, we will just copy paste from the other code. We need password, just see from here. We need URL, DB tables, user and password. Cool. So we need user, right? I remember my user of Postgres tables, so I'm having one user in my Postgres server. Its name is Ankur, and then I'm having some password. Cool. So my password is Nikki and James. I don't remember it, we will verify it. Okay, let me just pass the port also. By default port for me is 55432. Cool, perfect, this is done. Cool. Now we wanted to optimize it, right? So we have to set some other parameters also, but sometime it might happen that someone will not say all the parameter, right? So we will write our code, so which all parameter we need. So let me just copy the code from here itself. I think it will just save our time. Just give me 1 minute. I don't want to write this big line of code. It's very simple if else statement, you can understand it, not a problem. Okay, so we can either pass query or we can either pass DB tables. So when we are passing DB tables now, so we pass something like this, DB table, and we just pass the name of our table where we want to. Let's suppose my name of the table is Spark Bootcamp. Okay, but let's suppose we can also send some query. So instead of sending this DB table, we can pass query, and inside query we can actually write one value 𝗍eci query. We can write select star from table. We can write where, group where, or some conditions, group by and some conditions as t. We can also send the query like that. Okay, but we cannot send query or DB tables. Okay, we can either send one. So for now I've written this code. So if config.contains query and the config.contains DB table, if both are containing, then we have to send one, we have to throw one exceptions. We can either have query or DB table, we cannot have both. Perfect, I think this is making sense to you. Then I am written that if I am having query, then just add this in the JDBC map option, the map or dictionary, whatever you call. I am just adding this key value pair to this particular dictionary. If I am having DB table, then I am adding this DB tables. If I don't have either DB tables or query, so I have to again send one exceptions, right? That's the good way of writing code. Okay, then I'm checking if my config contains driver, then add this key value pair. Perfect, these are all very basic things. Now here comes the optimizations part. I can specify that how many number of partition I need while fetching the data. We have already discussed, right? We can pass number of partitions 10 or whatever. You can pass any number of partitions, but it is very much advisable that you should only pass the number of partitions, the max number of connections that a relational database can open. Let's suppose my Postgres can open 10 parallel connections, so I should pass 10. Okay, and it also depend upon the server for on which you are running your Spark clusters. It's very smart approach, but the very easy approach can be just see that what is the maximum number of connections that you can open, and try to, let's suppose your Postgres or your Oracle server supports 15 open connections, so you should pass 10, not near to 15, or 12 is also fine. Okay, so I'm just adding. So but I wanted to be sure that if somebody is passing number of partitions, then they should always pass this partition columns and the lower bound and the upper bound. Okay, I will not allow if someone is only passing number of partition but they are not specifying these three things: partition column, lower bound and upper bound. It's very much advisable that you should always pass number of partitions. Sorry, if you are passing number of partition, then you should always pass partition columns, lower bound and the upper bound. Cool. So if I have these four things, I am just setting this value. Cool. And how it is going to benefit me? It will create the multiple select query with the where clause. Okay, and I'm just sending one particular thing. Okay, it is saying something wrong because I'm returning mutable map. Cool. So this is the things, set JDBC connections. Now I don't need this, I will be sending this itself. Okay, and mutable map, perfect, mutable map, and this is done. Okay, here let's try to read the code. Perfect. In the JDBC connection we have not passed the right URL. Let me just see that what is the right URL. Okay, the util test. Okay, cool. Okay, so I was running from the test, so 1 minute. Why I'm passing the hard coded value? I should not do that, right? Config.url. oh, let me just do this get or else. Somebody might not pass that URL also, right? Throw new illegal argument extensions. Please pass URL as key, and I will do the same for it. So let me just not waste my time and let me just copy it from here itself. I hope you are getting it. I'm just trying to save my time, otherwise this will becomes very big. It's very easy, nothing fancy there. Get or else port throw new exceptions, and you can specify the exact exceptions. For now I'm using very broad exceptions, not a problem. Please pass the port as key. So I've written one modular code where I'm setting my value which is needed, right? Let me just check. Okay, extracted df, that's the first error. What is the next error? Okay, here I am going to write my code. Let me just use the try and except block because there might be some exceptions, right? So at least I'm just wanted to show that how you should write your code, but I'm also not specifying the exact exceptions. You should specify the exact exceptions actually, but not a problem. Throw new, I'm sorry, exceptions for now. E dot get message is fine. Okay, here I am going to write my code as spark dot read dot what is the syntax, load, right? But let me just see the syntax, I also don't remember it. Okay, the format we have to pass and the this we have to pass. Actually I also don't remember the syntax, I also see from the internet. Options, okay, let's call it as options. Perfect, this dot load. So and we can just pass the value, right? We can just pass the value and we can just test that how it is going to work. So let me just, I've already created one test classes from in that I will be running. Oh, this is not the test classes we need. Okay, so get data from where? Okay, let me just change this demo. Dot get data. Okay, so this we are calling with a Spark and the config, and here let's not pass this 4 things in the beginning. Okay, let's just try to run it. So I've also printed the physical plans. You will see that in the physical plant we are having only number of partition 1. So surely it will not utilizing the parallel things that a Spark provide, right? So we should increase it, right? The number partition is 1. There is no push filters, nothing is specific. It's very raw query. So if data becomes very huge, you will not able to fetch. It will take hours to just run the query and get the whole data in one single times. So we can do little optimization. There are multiple other optimizations possible. I am just saying one of the possible optimizations. So if somebody asks in interview, you should aware that there is something called number of partitions, there is something called partition column, there is something called lower bound, there is something called upper bound. Okay, so I'm just giving you the hint, and then you have to research, you have to read the documentations. Okay, let's just, I have specified number of partition, I have also specified the partitions column and the lower bound. Let me just run it now. You will see that number of partition will increase, and it also show the where clause, and it will fetch the data in very faster way. When you run this using any cluster like EMR or the Dataproc or any clusters, it will see that there is significant change. The amount of time that if some your old raw query was taking 1 hour, it will now takes max to max 10 to 15 minutes. That's it. So it's very much optimized because you are increasing the parallelism possibles, right? So let's just see the explain things. You can see here, right? Number of partition is 10, and you can see that it actually creating where clause. Seller ID 1010 and is null. Seller ID is greater than this. Seller ID is greater than less than this, greater than this. So it will create a very optimized query now, and it will try to do the parallelisms. And now Spark will try to load the data from any JDBC connection in much better way. I hope this will create a little spark in you to learn some optimization and learn how real world code is written, how you will start working on some data engineering project, then how you are going to take this up, how you are going to tackle this all these things. So it will give little bit of idea. I'm not giving you the 100 exact optimizations and the every other things, but it will at least give you some spark. So if we are learning Spark, there should be some Spark, right? So I'm just closing this video now because it's getting very long. But I hope you are able to get that we can do something. We can do something to fetch the data in an incremental way. We can do something to fetch the data in a very concurrent way. And we can optimize the parallelism that Spark provides. I hope it was helpful for you. If you have liked this video, please like it. Please do subscribe my channel and share with your friends who are working and trying to get into the data engineering domain. Thank you. Bye bye. Let's meet in the next video. Thank you.